After we realize the concept of the relational schema diagram and ER as well as EER diagram, you can find that there are a lot of similarities between them, but they are not exactly equal to each other. So this is the chapter for us to learn how to convert them from one to another. So in order to convert from ER diagram to relational schema diagram, we need to learn 7 different steps of doing that. When it comes to EER diagram, since there are 2 additional concepts, including the superclass and subclass concept, that is included in step number 8, and the concept of the union, which provides the OR concept, that will goes to step number 9. And therefore, let us take a look of these things step by step and learn how are we going to convert a ER or EER diagram fully into the relational schema diagram. By giving you guys an example, let's look into this ER diagram of the company database. It is exactly the same one that we have learned from our ER topic that includes the employee, department, projects as regular entity, and we also look into a dependent, which is considered as a weak entity type. Among those, there are multiple relationship connects to each other. We have one-to-one relationships. We have 1, 2, 3, 4 one-to-N relationships, and we have another M-to-N relationships. Among all of those one-to-N relationship, this is a recursive relationship. This is a weak entity, which indicates what entity does this weak entity belongs to relationship, and therefore all of these has their corresponding steps. Not to mention, we also want to handle the multi-value attribute, as well as how are we going to handle the M-to-N relationship. One minor thing I want to mention in this slide is that you will notice the derived attribute is not going to be converted into a relational schema diagram. Why is that? Because the derived attribute is actually considering as a function for us to do or to use this database. And therefore, that is not going to be included in the conversion, but it's going to be included in the query languages. So how can we make the query to generate this number of employees as a derived attribute? So let's start looking into the ideas of that. And of course, the end product is going to be a relational schema diagram. As you can see, we still have employee, department, project, and dependent, those 4 entities being converted into the relations. At the same time, you have works on, you have department locations that's trying to handle the multi-value attribute as well as the M-to-N relationship. So step number 1, we have to do things step by step from simple to a more complicated steps. The very first step is super straightforward. The regular entity types, which means that the rectangular box in the ER diagram. So for each regular, or what we call a strong entity types E, the entity we have in the ER diagram, what we need to do is simply create a relation R, which means we create a table in the relational schema diagram that includes all simple attributes of the entity. Choose one of the key attributes of the entity as the key attribute for the relation, which means we need to underline one of the attribute or attributes to form a composite primary key. If the chosen key of E is composite, this is exactly what I'm talking about. The set of simple attributes that forms it will together forms the primary key of the relation. So, for example, there are 3 regular entities, and we want to look into that one by one, employee, department, and projects in the relational schema corresponding to the regular entities. So what we are going to do is that we need to create those 3 regular relations and then try to identify their key attributes so that we will underline the key. Therefore, you see that we have this ER diagram starting by the regular entities. We underline red lines indicating employee is a regular entity, department is another one, project is another one. And we want to convert them one by one. So starting from the employee, I pick up the shot of the employee. Looking into this one, you will understand now I need to pick up all the attributes that I can collect. First of all, name is a composite attribute, and therefore I'm not able to just simply pick up a name as the attribute for the employee relation. Instead, I'm going to take the smaller or more atomic values that I'm using, first name, middle name, and last name, as the 3 attributes equals to the name. So all I need is those 3 simple attributes, which can give us atomic value. Next, I'm going to pick up the social security number as the primary key, and then I'm going to pick up birthday, gender, address, and salary for all of those attributes. And therefore, you can see that first name, middle name, last name coming from the composite attribute, social security number underline indicating is the primary key, birthday, address, sex, and salary. And therefore, you can see that that is the first step for us to convert the employees. You may notice that there are multiple lines over there, including a recursive relationship, including the relationship that goes to the department as well as the works on projects, those things. Don't worry about those. We will have step number 3, 4, and 5 try to handle all relationships. At this stage, we simply pick up those attributes goes with the strong entities. Next, department. This is a very interesting one because it looks super complicated. And let me show you, after the conversion of step number 1, you get only 2 attributes. How come? Let's take a look at this. Department itself has actually like 4 attributes over there. You have name, you have number. Maybe you can notice that both of them are underlined, indicating name and number are candidate keys. So in this case, personally, I prefer the number because that's the main purpose of why we need a number over there. So I'm going to under the D number as the primary key, pick up those 2 attributes. Now let's take a look of the rest of it. First of all, locations is a multi-value attribute. So it's not a simple attribute that I can pick up, and therefore I'm not going to touch it. There is one special steps to handle this one for any multi-value attributes. As I mentioned earlier in the earlier slide, the derived attribute is something that we don't want to be included because that is a function corresponding to a query database language. So we will save that part. For the rest of it, it has one relation, another relationship, another relationships. Like I said, step number 3 through 5 are the steps to handle different relationships. So I'm not going to do anything but pick up those 2 attributes for the department. Next, project. Project is the one that has 3 attributes. It has 2 attributes underlined indicating they are candidate keys. Again, I prefer numbers as the primary key because it will be easier to remember, easier to present, easier to store as well. Since it locates in single location, I only have 1 location over here, and therefore you can see that the project is created as a relation with 3 attributes, specifying that the P number is actually the primary key for the project. You can notice that there is some minor changes of the word I use for the attribute. The number is showed in the ER diagram over here. When it comes to the attribute creation for the project relation, I put a P number over there. That's some flexibilities because there's number used in project. There's also number used in department. So it might be easier to put a P number over here so that you don't have any duplications to create any confusion. For computer perspective, it doesn't matter because when I'm going to talk about the P number in the project, I would use project.number if I don't use P number. Even if I use P number, I still need to specify project.P number to indicating which attributes is the one I'm looking at as the most specific way of handling things. And therefore, after we go through step number 1, looking into 3 different entities. What we have is that first employee entity, next department entity relation, and then we also have the project relation over here. And therefore, you can see that we have 3 relations for the relational schema diagram based on step number 1. At this time, there is no foreign keys are specified, so we don't need to worry about those things since step 1 only works on the strong, or what we call the regular entity. Step number 2, this is more complicated. Actually, probably one of the most complicated step among all. For the weak entity types, because it is a weak entity, and remember, for every single weak entity, there is a relationship that has a double diamond indicating that which entity does this weak entity belongs to. So we need to handle all of these things. Connect this, create this entity, connects this weak entity with the belonging entity, and we also need to find a way to define the primary key for this weak entity. And therefore, let's take a look how can we do that. For step number 2, for every weak entity, W in the ER schema with owner entity type E. So E is the owner. W is the weak entity that we are looking at. And therefore, in our example, W specifies as the dependent, E specifies as the employee entity. What we need to do is we need to create a relation for this weak entity. Includes all simple attributes coming from the weak entity. Also includes a foreign key attribute of R, the primary keys of the relations that corresponding to the owner entity type. And the primary key is the combination of the primary key of the owners and the partial key of the weak entity type. And therefore, you can see this is more complicated. Not only you need to create a relation, we need to form our very first relationships in our relational schema diagram. So let's take a look at how is that going to happen. So in the dependent, as the example, we need to include a primary key social security number from the employee. Since employee is the belonging entity, we need to take belonging entity's primary key be included in the relation that we create for the weak entity. And let's take a look at that. So you see that dependent is a weak entity. It is belonging to the employee. How do we know that? Because we have one double diamond specified dependent belongs to the employee. So let's take a look. How do we convert this whole weak entity into a relational schema diagram? So step number 1. Create a relation called dependent, and then pick up all of the attributes that we can pick up. So we will be able to pick up dependent name. We can pick up sex, birthday, relationship corresponding to those 4 attributes. Now we need to form the link between dependent and the employee. So what we need to do is that we need to pick up the employee, the belonging entity's primary key. So we know primary key social security number. So I'm going to put a social security number over here, indicating that that is one that I belong to that one. And then we need to form a foreign key from the one that we included from the belonging primary key to the belonging relation. And therefore, you can see that we will form this foreign key referencing the social security number over there. And finally, the primary key of the dependent is the combination of the partial key plus the ESSN that we get from the employee entity. So that is the 3 steps that we need to take care of. And therefore, we will be able to create a relation for the weak entities. Like I said, it is more complicated than the regular entity since it is a weak entity. And that is, you can also see how important it is for any double diamonds for the weak entity. Therefore, once we have finished step number 2, remember in step number 1 we have 3 entities already, and now we have another relation, which is the dependent being converted, and therefore you can see that our relational schema diagram for the current stage consists of 4 relations and 1 foreign keys. In the next video, we will look into step number 3 through step number 5 that will help us to convert the relationships.